බජට් එක පාර්ලිමේන්තු එකේ කිව්වා කියලා දන්නවද? ඒක නෙත් බෑ. දැන් තමයි දන්නේ. කිව් සාවේක වෙන්න කියලා දන්නවද? ඒක දන්නවද? එන්නේ ඒ දාම එනවනේ. කී දෙනෙක් එන්නේ නේද? එවරන්සි මෙතන එවරන්සි නෑ ඉතව මෙසි නේ
Yes, one.
ඔව් ඊට පස්සේ අර නිදින ගල් අය ඉන්නවා ඉතින් හරියට ගියත් ඇතුළේ හිටියේ අපි මේ කාලේ අපි ලෙක්චර්ස් ගියත් කොහොම තමයි There's a band for you to take one and pass. Happy belated Valentine's Day. That's fun. Did I give you a calendar? Couldn't it? I did them again. Take my one and pass. Well, carbohydrates මතකද? Presentation එක බලන්න නැතුව කිව්වොත් what are the elements present in carbohydrates? Carbon, hydrogen, oxygen, nitrogen නේ. Nitrogen නෑ. Carbon, hydrogen, oxygen විතරයි. Well, in that case, there is a ratio between carbon, hydrogen, and oxygen. What is the ratio? Yeah, basically 1:2:1. When it comes to carbohydrates, so that we can study easily, we categorize carbohydrates into two as simple carbohydrates and complex carbohydrates. Okay. And then again, we had three categories. Munadi, monosaccharides, disaccharides, and polysaccharides. The simplest version is monosaccharides. As examples, for monosaccharides, we discussed three examples. What are they? Glucose, fructose, galactose. Those are the three. Out of those three, what is the sweetest one? Glucose, fructose, or galactose? Fructose. What are the examples that you remember about disaccharides? Hmm? Maltose, sucrose, well, speaking of a sucrose molecule, what are the two molecules joined together? How to make a sucrose molecule? What are the two monosaccharides involved? Hmm? What and what? Glucose and two glucose. No, glucose and fructose. Yeah. That reaction is called as a condensation reaction. Why is that? As a byproduct, H2O molecule is formed. What is the disaccharide which is found in milk? Lactose. Yeah. What is the situation, the health issue called lactose intolerance? මතකද? මොන වගේ එකක්ද ඒක? Yes, very good. Inability to digest lactose. එතකොට මොකද වෙන්නේ intestine එකේදී? It absorbs water. Right. Then the intestine becomes dehydrated. Then the body rejects that. So we end up in diarrhea. You know, basically, discomfort. And when it comes to polysaccharides, we need two major ones. One is starch, the other one is glycogen. Where do we find starch and where do we find basically what is the main major source of starch and what is the major source of glycogen? Starch is coming from plants, glycogen is coming from animals. Yes. Well, when we test a simple carbohydrates by using Benedict solution, uh, what is the observation? Hmm. Dark blue තමයි initially. ඒක මොකක්කටද convert වෙන්නේ මොන පාටද? Reddish brown precipitate. Yes, correct. Right. That's previously on carbohydrates. This is for you. Right. Okay. Any other point which you did not understand from the previous lesson? Last week? All right. What are the control? Right. Okay. Carbohydrates done. So we are coming to proteins. Another familiar topic. Proteins. Right. We know we have like animal proteins and plant proteins both. But when it comes to proteins, what do we remember? Major and animal source, right? Yes. Right. So when it comes to protein, when it comes to carbohydrates, the composition, the elements wise, we had carbon, hydrogen, oxygen. Only those three. But when it comes to proteins, we have carbon, hydrogen, oxygen. In addition to that, we have nitrogen and sulfur as well. Not compulsorily, but nitrogen and sulfur also. All right. Right. Well, basically, the major the major application of proteins, right? Basically, it is a structural component of the elements, right? So we entirely from top to bottom, we entirely comprise it. Our structure is made up of proteins. Starting from here, keratin protein, up to the bottom, entirely proteins. So structure is made up of proteins, which is why like we meat is like we say chicken, fish, or whatever. That is protein because the entire structure of the animal that is proteins. So basically, it is major structure. Like mainly, it is a structure. Well, and also control molecules. That is important inside the body. Inside the body, all the chemical reactions, right? Anabolic reactions and catabolic reactions. In general, we say metabolism, maintaining the chemical environment inside the body. That is totally handled by enzymes, right? So enzymes are proteins, right? And also, uh, in the body, transport material. Basically, when from the body, like okay, different materials have to be transferred from one place to another place. It's a compulsory thing, right? Starting from oxygen, right? Oxygen has to be transported from lungs to the other tissues. Carbon dioxide has to be transported from the other places, other tissues to the lungs, right? That is just an example, some random example which I will just remember. Likewise, this messenger job, the transport job, that is done by proteins. Okay, right. So when it comes to all these proteins, the building block, that when it comes to carbohydrates, we are talking about the building block, monosaccharides, right? Likewise, here the building block is amino acid. right? The term amino acid also is not an unfamiliar word to us. We know about amino acids. So, right, amino acids, right. So, those are the general things. Well, proteins. When it comes to proteins, we can't forget about to any type of organism. The proteins are the ones which are giving the structural support. Entire structure, like we were talking about before, also entire structure is built by using proteins, and so that is what we call structural support. Tissues, muscles. Hmm? Right. Without that, like, just imagine like that bones and everything, they won't exist. Bones, skull. So all these things that it is held together by muscles, that is proteins. That is what we call structural support. And storage inside the body, right? The things are not just lying, they have to be stored. The storage job is done by proteins, right? Transport of substance we're talking about, and intercellular signaling. Intercellular signaling from one cell to another cell, right? There should be proper coordination, right? There should be proper coordination. As an example, all of a sudden, let's say that, okay, we see a snake coming here, right? Right. So then our entire body has to function as just as one unit, right? So either like we have to run away or hammer the fellow, the whatever it is, right? So we have like so then just imagine like if it is ready to run away, then again we are searching for from hand we are searching for another thing to hammer the one. That's not done. So then cell to cell there should be proper communication to one thing. Otherwise, like what happened to Sri Lanka, we have everyone is pulling to all the sides. So then all the entire last 76 years, the Sri Lanka is the same place. Now only it is being pulled to one side, right? So then that can't happen like that. So the entire like so it has to be like coordinated in one way, right? So this is what we call intercellular signaling, right? Then the coordination will be there. So we need proteins. Remember these things like these parts like you know that you have written assignment also, right? Uh, in addition to the final examination. So be aware about all these things. You need to research before you write the assignment. Right. Anyway, defense mechanism, right? Again, foreign substances. That is about our body's infected, like we are attacked by bacteria, fungi, virus, right? So inside the body, we have there is a defense mechanism, right? So we are fighting against this. Then we have proteins is one which is doing that function. Well, so enzymes play the role of handling the chemical reaction side. This is how this happens. Well, speaking of chemical reactions, our body, it is not just limited to one or two chemical reactions, right? Even in glycolysis, Krebs cycle, those stuff we were talking about, like there are so many reactions happening, right? Thousands of reactions happening. For handling all those reactions, we need different enzymes. Enzymes only run these all these chemical reactions. Basically, so those are the like major uh, functions. Well, amino acids, so proteins. Then we come to the level of amino acids. Remember, there are around like in the nature of there are around 20 different amino acids, right? Around like 20, 21, 22, that's the range, maximum. All those proteins, enzymes, made up of different sequence of those amino acids. Okay, right. Yeah, question. Right. Okay, now let's come to the structure of amino acid. When it comes to amino acid, you see, this is the structure of an amino acid. Now, you see, we have a carbon atom right here, right in the center. Around the carbon atom, we know carbon belongs to group 4, so there are 4 bonds around carbon atom. Out of the 4 bonds, one must be in NH2, right? NH2, nitrogen and 2 hydrogens. We call it amino group. Amino group. Remember, amino group is performing as a base because on the first day itself we discussed about acids and bases. Remember, acids are the substances which releases H plus ions to the medium. It could be a very simple acid like this, or else it could be a carboxylic acid like this. Like this. Okay. Acids. Bases. Now, acids release H plus ions. Bases, they gain H plus ions. Now, we'll say ammonia, not related to this at all. Okay. So, ammonia, it can gain an H plus ion to form NH4 plus ion. Since it is able to gain an H plus ion, that is ammonia is a base. So, how it is happening? There is a lone pair here, a pair of electrons. It can capture NH plus ion, forming NH4 plus ion. Right? So that is handled by the electron pair, which is present on the nitrogen atom. Now, when it comes to this one, you see, we have an NH2 group here. And though I haven't mentioned it, so there is a pair of electrons on the nitrogen atom. Then this NH2 group is capable of gaining H plus ions. Right? NH2 group is capable of gaining H plus ions. Which is why we say that we call that amino group. Amino group. Then amino group is it is possible to get an H plus ion. So it is basic alphabet. It's a base. That left side H, it doesn't have the left side. Okay, so that in the diagram that I have drawn, it is on the left side. So that is basic. Right side, you see, there is a C double bond OH group. C double bond OH group. Now I have taken an example right here. C double bond OH group, this part. It can release H plus ion. That means that part is acid. All right. So then this right side is acidic. Okay. That is acidic. Right. Around the carbon acidic. මේ පැත්ත base, මේ පැත්ත acid. ඇයි අර පැත්ත base වෙන H+ ගන්න පුළුවන්. ඇයි මේ පැත්ත ඇයි අර පැත්ත base වෙන H+ ගන්න පුළුවන්. මේ පැත්තෙන් H+ release කරන්න පුළුවන්. අර විදිහට අර O එකයි H එකයි කැඩිලා H+ ගැලවෙනවා. Right. So this side is acidic. Right. Bonds දෙකක් හරි. තව දෙකක් තියෙනවා. And one must be hydrogen. Right? And the other one is an R group. Remember this R group, I will show examples. R group could be anything. One amino acid changes from another amino acid by changing the R group. It could be hydrogen, it could be CH3, it could be CH2, CH3, it could be anything. So just for now, it's just randomly that we say the R group can change. It can vary from 1 carbon atom to 20 carbon atoms. Right? Right. So this is the structure of amino acid. The point that I want to highlight is this acidic part is able to release H plus ion. The alkaline part is able to get, basic part is able to get H plus. All right. Well, you know, normally acids release H plus. That released H plus is gained by base. So I think of any decoding make acid na making H plus release කරනවා. මේක base na අර release කරපු H plus එක මෙයා ගන්න. හැබැයි amino acids වල ওই දෙකම තියෙන නිසා the H plus which is released by one end of the amino acid is going to be gained by the other end of the same amino acid. හරිද? H, R, N, H, H. I'm drawing the lone pair here. Well, this H plus is removed. And that is gained by this side. Right. Then we're going to H, N, H. අර අලුතෙන් ආපු H එක C H R C double bond O O මෙතන H එක ගියපු නිසා මෙතන මයිනස් වෙනවා. හරිද? අලුතෙන් H plus එකක් මෙතෙන්ට ආපු නිසා ඒක ප්ලස් වෙනවා. So this is something like self-neutralization. Acid-base reaction is what we call neutralization reaction, right? In general. So this is self-neutralizing, right? So if we keep an amino acid alone, it exists in this form, right? H plus is given, this H plus is given. We call this structure, this is just the structure of just amino acid. This is the Switterian form of amino acid. What form? Switterian form. Switterian form of the amino acid. For any amino acid, any random amino acid which is given to us, we can draw this structure. Very simple thing, don't worry. Just remove, just find the COOH part. කොනේ තියෙන හයිඩ්‍රජන් එක හොයා ගන්න. ඒක ගලවන්න. ඉතුරු වෙන ඔක්සිජන් එකට මයිනස් දාන්න. ඒ ගලවපු හයිඩ්‍රජන් එක කොනට ගේන්න. NH2 NH3 කියලා දෙන්න. එතෙන්ට ප්ලස් charge එකක් දාන්න. මහලු දෙයක්. And so that is Switterian form of amino acid. Right. So NH2 group is fine. COOH part is fine. Hydrogen atom is that is constant. That is also fine. And R group. Okay, let me talk about this R group. When we change the R group, the entire amino acid changes. This. Right. The first one, glycine. R group is hydrogen. Right? Alanine another amino acid, different properties, and everything is different. Alanine, our group is CH3, one carbon atom. In all these cases, you see, do you notice that OH is O minus and NH2 is NH3 plus? That means that self-neutralization has happened in all these cases, right? Anyway, alanine, our group is a CH3, one carbon. Valine, there are 3 carbon atoms. Leucine, there are 4 carbon atoms, R group. Isoleucine, there are 4 carbon atoms, but a different arrangement. Methionine, there are 3 carbon atoms, and there's sulfur inside, inside the R group, which is why, like, in addition to carbon, hydrogen, and oxygen, we have sulfur and nitrogen as well in amino acids in proteins. Okay. Phenylalanine. In that case, CH2. This is the ring structure. I hope you can remember that is benzene part. Do you? So that is when it is just a substituent group, we call it phenyl. So phenylalanine. Tryptophan. It is a nitrogen-containing amino acid. We have 2 ring structures there. Nitrogen is present. Proline. That R group is connected with the nitrogen atom. Like that. See, R group changes everything in it. Right? So by changing the R group, we can change the amino acid. Let me show some more examples. Right. Serine. There is an alcohol part. Right? But we can't get drunk by drinking that. Okay. That is CH3, CH3, CH2. That is ethanol. Right. OH is present. Right. Threonine. That is also OH containing amino acid. Cysteine, a sulfur containing amino acid. 1 carbon is also present, CH2SH. Tyrosine, benzene, a CH2, benzene, and OH. Right. Right. This one. Remember, RNH2. These compounds are called as amines. R C double bond O NH2. They are called as amines. Amines. So, in this amino acid, you see, there is an amide part. There's an amide part. In this case, there's 1 more carbon atom, glutamine. You see, with the R group, amino acid changes. Let me show some more examples. Right. That one, aspartic acid, the first one. That has a carboxylic acid. As the R group, it has a carboxylic acid part. Carboxylic acid means R C double bond O OH. Carboxylic acid. As an example, CH3 C double bond O OH. Like that. So, aspartic acid, that is a carboxylic acid part. Glutamic acid, It also has a carboxylic acid part derivative and the number of carbons increase by 1. Right. And this one is a nitrogen containing one. And this one also, right? Yeah. Lysine also. So now you know about different types of amino acids. NH2 compulsory, COOH compulsory, hydrogen atom compulsory. By changing the R group, we can have like number of different amino acids. Clear? Right. Right. Question? No. Same. Ah. Well, we'll talk about some common amino acids. You might have heard about glycine, right? Have you? Mothergan. Good. So this is one of the simplest amino acids. COOH compulsory, the red one. NH2, the blue one is compulsory. The black hydrogen is compulsory. R group is hydrogen here. That is the simplest version. In all the other amino acids which we were talking in our previous slides, they were big, right? Some is free, sometimes the big phenol part, uh, alcohol part, carboxylic acid part. This is the simplest version, right? So amino acid, well, well, I need to talk about another thing. When it comes to amino acids, අපිට amino acids කොහෙන්ද හම්බුනේ? කොහෙන්ද හම්බුනේ? ඒක හම්බෙන්නේ වෙන්නේ. Basically external sources. හැබැයි මෙහෙම එකක් තියෙනවා. Amino acids වර්ග දෙකක් තියෙනවා. Depending on whether we eat or not. Essential amino acids and non-essential amino acids. Right? Essential amino acids and non-essential amino acids. Essential amino acids means, yeah, essential. Simple like that. Non-essential. Can be old amino acids. Old amino acids, ne. But there are two categories called essential amino acids and non-essential amino acids. We need both of them. Then why do we call some of them as non-essential? Can you please? Yeah, what do you think? Are you right? The body is producing those amino acids. Right. So remember there are two categories of amino acids as essential amino acids and non-essential amino acids. Essential amino acids. Essential amino acids must be taken from outside. Outside කියවහම දෙකක් තියෙනවා. එකක් food. අනිත් එක supplements. හරිද? ඔය දී විදියට ගන්න පුළුවන්. Right? Those are essential amino acids. Non-essential amino acids, we don't have to take. We don't have to take. It's not compulsory because the body is making it. Right. So this categorization is done whether we make that, whether we produce that amino acid inside the body or not. Well, right. So then the amino acids which we are talking here, right? Some are essential, some are non-essential. Right. So let's come back to glycine. Lysine. Lysine is an amino acid which can be produced in the body. It can be produced. That hydrogen atom, right? So then put idea people that me R group එක විදිහට පොඩි පොඩි කෑල්ල කියනවා produce කරගන්න පුළුවන්. පොඩි. අඩි R group තියෙනවා එහෙම produce කරගන්න බෑ. එතකොට ඒක අපි either food or as supplements we have to take. Fine. So this is produced by the body, but can be taken as food also. Meat, fish, dairy products, legumes, right? So, yeah. So, inside the body, glycine is used to make proteins. Remember now, protein actually, you don't have to mention all the time like protein is it is used to make the structure of the body, not a food source. Again, I'm sorry, what do I say? Not an energy source, right? Energy is coming from carbohydrates and lipids and stuff. You remember we were talking about the glycolysis cycle and stuff like cellular respiration, ATP generation and stuff. So those stuff actually. So energy is coming from those, not from protein. Protein වලින් energy ගන්න වෙලාවකුත් තියෙනවා. හැබැයි ඒ last moment, just imagine that okay, you are deserted in an island group somewhere alone, no food. Like Oliver Queen, have you watched Arrow? He was talented, so he survived. Right. Anyway, just imagine like you are totally run out of food. Right? Okay, we have carbohydrate stuff for your body consumes that. And any of the and have it fine. The carbohydrate, right? It was a fat. Fat layers of the fat filling energy. Right. Food giver. Hari dengan duskara kriya කරාවගේ look එකක් තියෙන්නේ fat giver. ඊට පස්සේ last option එක විදියට proteins වලින් energy ගන්නවා. මොකද දැන් heart එක වැඩ කරන්න ඕනේ. ඒ කියන්නේ compulsory ටිකක් තියෙනවා දුස්ම ගන්න ඕනේ. ඒකට energy ඕනේ. ඇයි මේවා? වැඩ කරන්න ලක්ෂණ කරන heart එක වැඩ කරන්න ඕනේ. brain එක function වෙන්න ඕනේ. ඔය තුන වැඩ කරන්න නැත්නම් දුක් වැඩි වෙන්නේ නැහැ. Right. එතකොට ඔය තුන ඒකට අනිවාර්යෙන් energy ඕනේ. Right. එතකොට last option එක විදිහට දැන් carbohydrate ඉවරයි. ගන්න නැහැ. lipids ඉවරයි. Last option එක විදිහට proteins දිය කරලා ඇඟේ තියෙන structure එක දිය කරලා energy ගන්න. ඒ last option එක. හැබැයි ඒ ටික වෙන්නේ නැරෙන්න ඕන කියලා තියෙනවා මොකක්ද? ඒ ඊට පස්සේ survive වෙන්නේ නැහැ. last option එකේදී ඒ අන්තිම තත්පර ගන්න survive වෙන්න උස්ම ගන්න ඒ lungs වැඩ කරන්න heart එක pump කරන්න brain එක වැඩ කරන අන්තිම ගන්න ATP ටික ගන්න තමයි ඒ protein structure එක ගන්න. ඒ කියන්නේ last moment it was that. Protein is never used as an energy source. හරිද? ඒකෝට structure build up කරන්න තමයි ඒක ඉතින් දැන් body building මොනවද කියන්නේ? Right? ඒකෝට structure protein supplements ගන්නේ and structure muscles හරි energy source එකක් විදිහට. Right? ඒකනේ දැන් ජිම් යනකොට දැන් අපි දැන් probably range energy වෙනම අරන් යනවා. Right? energy source වෙනම තියෙනවා. ඒකකට protein කියන්නේ right, okay. So that's a different story. So then glycine, right. Let me talk about another example. Right. Tryptophan. Right. Amino acid. So this is a structure. Right? This is a structure. In this structure, you see the particular middle central carbon atom. Do you notice that? In amino acid, there is a special carbon atom which has COOH, NH2, H, and some random R group. Those four. So in this case, did you click where that particular special carbon is? Rings දෙකක් තියෙන පැත්තද අනිත් පැත්තද? Rings පැත්තේ. අනිත් පැත්තේ. අපි ටිකක් ඉලෙක්ට්‍රික් ගත්තාම ටිකක් අපේ අනිත් පැත්ත හරියන්න බැහැ. බෑ නෑ. ring පැත්ත නෙමෙයි මේ පැත්ත. This is the carbon atom. Right, in this carbon atom. Down NH2. Right, COOH. Left අර තඩි R group එක. Up, nothing is drawn. It's hydrogen. Right. So that is the amino acid. Well, so this is in the infants for normal growth, right? And maintenance. This is this tryptophan that is used. All right. And this is an essential amino acid. The previous one that we were talking about, what was that? Glycine. Yeah. Glycine is not an essential amino acid because the body can make it. Right. This one is this is an essential amino acid, so the body can't make it. Right. So you see, then if the body is unable to make it, if we don't take it from external sources, obviously that particular function will not be done. හරි ඒකෙන් හදන්න තියෙන ස්ට්‍රක්චර් එක හැදෙන්නේ නැහැ. So ඒ කැලේ නැතුව තමයි වැඩේ. Right. Incomplete. Right. Now you have the basic idea about amino acids. Well, speaking of reactions of amino acids. They react with acids. Why? NH2 part is a base. Let me take it here. Right. This is NH2 part. There's a lone pair over here, electron pair here. It captures this hydrogen. NH3 now, positive, and Cl minus. Right. So this is the reaction with acids. Not only that, they react with bases also. Why? Because there's an acidic residue. Right. Base, let me take sodium hydroxide as an example. Right. So amino acids can react with acids, can react with bases as well. වැඩි යූස් කරන වැඩි ඉන්වෝල්ව් වෙනවා. ඒකට සෙල්ලම් එක ෆෝන් එක අල්ලගෙන ඉන්න ඇල්ලුම් එනවා. තව ජෙනරේෂන් තුනක් යනකොට මේ පැත්තෙන් චොටක් තව ටිකක් අර ටච් කරගන්න. පස්සේ ඉගෙන කියන්නේ මේ අර එලිමිනේෂන් කැලේ නෙමෙයි අර ඩෙවලොප් වෙන එක. ඒකම එලිමිනේෂන් අර බලි ගේම් එලිමිනේෂන් නෑ. ඉස්සරහට එලිමිනේෂන් ආර්ථික කැලේ අර වැඩි යූස් කරාම වැඩි හැදෙන්න. ඒක දියරි තමයි තියෙන්නේ. එහෙම තියෙනවා. අපතේ නේ වලි. වලි Right, quickly complete this reaction. I see. Right, හරි නේද? This is a base. Since it is a base, it reacts with the acidic end. Right, this is acidic end. Then nothing happens to NH2 part. Nothing happens to H. Nothing happens to CH3. Right, C double bond 4 O. Right. We know sodium belongs to group 1, so it is +1. But calcium belongs to group 2, so it is +2. So we need 2 of them along with calcium. Right. Then two H's are there, two OHs are there, then two H2O. Right. Write the reaction between this amino acid and sulfuric acid. Sulfuric acid, no. Base, basic here. Then nothing will happen to COOH. So NH2 will gain hydrogen and will become NH3 plus. There are two hydrogens. Right. Then we need two of them to gain both the hydrogens. And remaining one is SO4 2 minus. This is how we write the reaction. Right. That's about the reactions of amino acid with acid, a base, right, and with another amino acid. When an amino acid reacts with another amino acid, you see, this is, yeah, so the left column one amino acid, there this is another amino acid. Right, this one has acidic end, the other one has a basic end. Between two amino acids, there is an acid-base reaction happening. Right. And that OH goes to this hydrogen to form a water molecule. Right? Water molecule is a byproduct which I haven't mentioned here. Right. So then that carbon is going to be connected with this nitrogen. Right. So this is the molecule. This is a reaction between amino acid and with another amino acid. Exactly similar to what we were practicing before. All right. In the previous case, amino acid plus a base. So here, this amino acid plus a base, the basic kit. An amino acid plus an acid. This amino acid reacts with an acid, whereas this is acid. So here also there is an acid-base reaction, not anything else, nothing big. The byproduct is, they are in the first reaction is water. So here also the byproduct is water. A condensation reaction because water is formed as a byproduct. Right. So what we get here is a dipeptide. Right? Two amino acids react together to form a dipeptide. We discussed about a similar type of reactions last week also. Monosaccharide and other monosaccharide react together to form a disaccharide. Here also amino acid reacts with another amino acid to form a dipeptide. Right? So this is the reaction, and this is a new bond which is formed. Clear? Right. So when two amino acids react together, what we get is a dipeptide. But we know that it doesn't have to be just two amino acids because both the amino acids have another two edges, right? So it can continue. When three amino acids react together, basically a dipeptide, when dipeptide reacts with another amino acid, or else we can say the reaction of three amino acids, that is a tripeptide. Is more than three, a very long chain. We call it a polypeptide, right? Loads of amino acids react together to form a very long chain, which is a polypeptide, a polymer chain, right? So here I have shown some reaction here. Carboxylic acid, amine, acid base. Carboxylic acid, amine, acid base. Right? So the reaction continues. Likewise, here three water molecules are formed because it's a reaction between three amino acid molecules. And so this can be continued. This is how a polypeptide chain, a very long chain, is formed. So those are polypeptides. After forming the polypeptide, that can be arranged in different ways. That's a different story. Well, so that's when it comes to like long protein chains. Well, if I show the bonding structure, right? I've taken some random amino acids, right? So in each case, the water molecule is removed, right? Then this is going to be at the final amino acid sequence, the protein, right? So then when the protein sequence, when the amino acid sequence changes, the order changes, the protein changes. Let's think about just think about two amino acids called amino acid A and amino acid B. Yeah, let's say. So combination. We can have AB, 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 one protein, right? AAB, 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 another sequence, another different protein, right? ABA, ABA. So then likewise, even with just with two amino acids, we can have like uncountable number of different uh, sequence, basically different proteins, which is why just with around 20 different amino acids, we have like thousands of different proteins inside the group. Right. Well, more diagrams about that peptide bond. The peptide bond, the bond that I'm highlighting is this bond actually. Where is it? This is the bond that I'm highlighting here between C double bond O carbon and NH nitrogen. That bond. All right. The bond between C double bond O carbon and NH nitrogen. That bond is what we call peptide bond. What bond? Peptide bond. So this diagram shows which one? This one. Yeah. This diagram shows the peptide bond between that particular carbon atom and the nitrogen atom. Basically, between C double bond O carbon and NH nitrogen. This bond. Well, so now we know about polypeptide chain. Let's say that we have a like very long polypeptide chain, long chain, right? So a very long chain like this, a very long chain like that, we call it a primary protein, a very long chain, right? Just like this. We call this wire, flexible mass, right? A long chain, primary protein. ඔය වයර් එකම අපි මෙදින් අල්ලගත්තොත් ඔකන මුකුත් නැහැ පල්ලහැට කැලෙන්නේ නැහැ කැලෙන ටයිප් එකක් වුණා නම් right it just just falls and right that you can imagine that structure no that it becomes like a helix kind of structure right that structure that is a secondary structure secondary protein so primary protein secondary protein අර මැදින් අල්ලලා ගත්තා පස්සේ මේ මාර කඩා හැදෙන ස්ට්‍රක්චර් එක. හරිද? ඕකම අපි මෙන්න ගුලියක් වගේ ගත්තොත් as a lump that is a tertiary protein. Right? A big lump. Tertiary protein. මේ වගේ collection එකක් ගත්තොත් together right that is a quaternary protein. Then after making the polypeptide chain, according to the arrangement, we have primary, secondary, tertiary, quaternary protein. There are 4 types of structures. Right. So this is about that. And a glass and another chair. And we make going to the right. This is another diagram. This is another diagram about primary protein. primary protein, right? Straight chain structure, right? Secondary one, අරමං කියපුවා ඉදිමිනල් ගත්තට පස්සේ alanine structure එක නේද? That is secondary one. එතකොට අර alanine කර sheets වගේ තියෙනවා. හරිද? පොඩි protein දැන් polypeptide chain එක කියන්නේ අර නිම කුලක් වගේ එකක් නෙමෙයි නේ. amino acid එකක් ගත්තට පස්සේ ඒකට මේ යම් thickness එකක් තියෙනවා. හරිද? එතකොට මේක අර නිවුලක් වගේ තියෙන එකක් ලණුවක් වගේ තියෙන එකක් නෙමෙයි ෂීට් එකක් වගේ තියෙන එකක්. You get it? ෂීට් එකක් වගේ තියෙන එකක්. Because like it has a thickness. Right. So this is how those sheets are there. So they can be parallel to each other, or else they can be helix, right? So we call it alpha helix. Right? So, and the beta sheet, right? Likewise, so that is the arrangement. Secondary. Tertiary. Tertiary කියලා කිව්ව අර AD bits එක අර බුලියක් වගේ එකක් හරිද? Right. That is that. That's how like so naturally that exists. Tertiary part. Right. And that helix structure about secondary one, if I talk about, yeah. I just want to show this diagram. I wonder whether that is clear enough. Yeah, so this is how that helix structure exists. That is a helix structure. The sheet protein excellent නීති වතයි. AC එක කෙලින්ම නෙමෙයි. Right. Okay, that is a sheet structure. I know that there's a thickness for the chain, right? Molecule, the sheet. So this is how. When it comes to the sheet, remember the sheet, that very long one, that can exist as a parallel one, right? And the anti-parallel one. So what is this difference between parallel one and anti-parallel one? Right? The sheet, parallel one. So then of course, yeah, look at these arrows. So they exist in one direction. If they need to be in the full one. If they exist in one direction, that is parallel one. And if they exist in opposite direction, that is anti-parallel one. Right? Direction, what do I mean by direction? Right. first protein synthesis part again. Right. So direction so that we can so 5 to 3 direction. So in simple meaning, in the polypeptide chain, one side is NH2. එහා ගොන C double H. Right. එතකොට parallel කියන්නේ අපි sheet එකක් ගමු. එකක් NH2 මේ පැත්තේ C double H අර පැත්තේ. තව එකක් ගමු. NH2 මේ පැත්තේ C double H අර පැත්තේ. අන්න parallel. Anti parallel කියන්නේ එකක් මෙහෙම යනවා අනිත් එක අනිත් පැත්තේ. Right? Both are possible. Right. Okay. So parallel, anti-parallel, piston. Right. So you can have an idea about that by looking at this diagram as well. Question? No. This is the molecular diagram. So this is the previous one is like, so just direction and stuff. So then this is a molecular diagram. You see, that's how the sheet exists. The directions which I was showing in the previous one, this side and the other side, right? So like that. That is a molecular diagram. Right. And protein structure. So, the polypeptide chain and helix, parallel, anti-parallel chain and loops. So then this is the loop structure. Right? Loop structure. By using the loop structure only, they become like big lump. Right. So like that. Basically, this is becoming like kind of a coil structure. Right. This is how it naturally is. When the chain doesn't exist like just a chain, when it becomes like, so you hold it and it becomes, then you see what is happening here. The different parts of the same chain are getting attracted to each other. Right? There are some intermolecular force like called hydrogen bonding. Some might remember, some don't, but it doesn't have that type of an intermolecular force. Because of that, because of those bonds, same, even within the same molecule, within the same chain, different parts are getting attracted to each other. Right? So that's how it becomes loop, like coil. Right. Now we'll talk about some selected proteins. Albumin. Obviously, you would have heard about albumin. Right? This protein actually can be synthesized in the liver. First of all, right. Albumin protein that enters to the bloodstream and then goes everywhere. Because of that, the fluids are not going to leak into the vessels, like out of the vessels into the tissue. Then, as an example, you see, like in case if the fluids leak, right? Fluids are supposed to go in the tubes. Now, if they leak out, they go into the tissues, right? Now, some cases you see that we get some swollen situations, health issues, right? That is because fluids are getting leaked, right? So, albumin, basically, it prevents these fluids from leaking into the tissues, right? And also, it has some transport job as well. Hormones, vitamins, enzymes, right? So the transport job is being done by the protein albumin. Another one. Glutathione. Another example. Right. It's another protein, another important one. It is made by using the amino acids glycine, cysteine, glutamic acid. In the previous slides, we at the very beginning we were talking about glycine, cysteine, glutamic acid, all the three amino acids, right? So the reaction between NH2 part, COOH part, NH2 part, COOH part, like that. So by using these three, these amino acids, this protein is made, right? And this is also produced by the liver, right? That is also produced by the liver. Well, so speaking of the functions, so these are the third point is talking about I'm talking about the functions of glutathione. Well, this is a structure. Okay, right. Now we'll come to some familiar protein. Hemoglobin. You're highly familiar, right? About hemoglobin. Right. This is a protein. We find it in red blood cells, RBC. Right. The job of hemoglobin is to yes, transport oxygen and carbon dioxide both actually. Right. Right. So that is in red blood cells. If we run out of uh, so the situation, right? Red blood cells, and then of course iron deficiency and stuff, right? Finally, we call that situation anemia. Okay, so this is the structure of hemoglobin. Now, why do we call it anemia? Hemoglobin. In Latin, heme means iron, right? Iron is present inside. In this protein, iron is there. So iron, basically, iron is not that iron is there, iron must be there. So if we don't take iron enough, then what will happen? Hemoglobin will not be there. So hemoglobin is not just the protein part only, so iron is included. If you don't have enough iron, then hemoglobin, the heme part is not there, so hemoglobin is not there. Right. So then we have that problem. Health issue. What is happening in like hemoglobin? So what is happening in the lungs? In the lungs, hemoglobin, this molecule, reacts with oxygen and it forms oxyhemoglobin. Right? Oxyhemoglobin. Right. When we breathe in, we take normal air. Oxygen is there and have a little bit of carbon dioxide oxygen. That's a different story. So yeah, when we inhale, yes, hemoglobin reacts with oxygen to form oxyhemoglobin. Then what happens? This oxyhemoglobin through blood, it is transported to different areas of the body. It goes to tissues. Tissues may be and very variable. Right. Then what is happening? Hemoglobin, the reaction between oxygen and hemoglobin is not a permanent reaction, it is a reversible reaction. Right? What do I mean by reversible reaction? Hemoglobin reacts with oxygen to form oxyhemoglobin. At tissues, so the reaction which I was talking about is happening in the lungs, right? Then that oxyhemoglobin is broken back to hemoglobin and oxygen in the tissues. I repeat,
Hemoglobin reacts with oxygen to form oxyhemoglobin in the lungs. And oxyhemoglobin goes to tissues, that is different body parts. At the body parts, oxyhemoglobin is broken back to hemoglobin and oxygen. So this is a reversible range. All right, right. Then oxygen is released to the tissues. Then that oxygen is used up for ATP generation, blah, blah. So they will evolve with that part. So oxygen is utilized. Now hemoglobin is free. Okay. Right. In the tissues, carbon dioxide amount is high. Now what is happening? The same hemoglobin which is released from, which is free from oxygen, right, reacts with carbon dioxide, forming carb-aminohemoglobin. Carb-aminohemoglobin. That carb-aminohemoglobin, through the blood, it goes to the lungs again. Right? Right. At lungs, carb-aminohemoglobin is broken to form hemoglobin again and carbon dioxide. Right. That carbon dioxide, we exhale. Right. So this is how the oxygen carbon dioxide transport is happening. Understood? Then reaction between oxygen and hemoglobin is reversible. It's broken back. And also the reaction between hemoglobin and carbon dioxide also is reversible. Broken back. Well, tell me why it is harmful to inhale carbon monoxide. Why do we die because of carbon monoxide? Again, reversible, nay. Reversible, nay. Because in that story which I was talking about right now with carbon dioxide and oxygen, hemoglobin goes to the right place and it becomes available again. Right? It becomes available again. But if we inhale carbon monoxide, what happens? Carbon monoxide combines with hemoglobin, and that molecule is never broken. And that particular hemoglobin molecule is never going to be free. Right? That is permanently blocked. That is permanently blocked. That means hemoglobin becomes totally unavailable. Right? Then when we inhale, what happens is every single molecule of hemoglobin which exposes to carbon monoxide becomes blocked, unusable forever. Right? Then what is happening? Oxygen is available in the atmosphere. We breathe in also, but from lungs onwards, oxygen is not going. Why? There's no one to transport oxygen. Then we die without oxygen. Right? So that is what is happening when we inhale carbon monoxide. Clear, right? That's how we die from carbon monoxide. How do we die from cyanide? Not really this in general. Cyanide, මතකද LGT එක use කරේ cyanide. අර බෙල්ලෙල්ලන් ඉඳි. මතකද දන්නේ නේ? බෙල්ලෙල්ලන් ඉන්නේ capsule එකක් මේම. මේ වගේ එකක් මේ ඊට වඩා පොඩි එල්ලන් ඉඳි ඊට පස්සේ ආමි එකට ආපුට ගමන් ටක් ගාලා ඒක අනම. ඒක ග්ලාස් වලින් කරලා තියෙන ඇතුලේ cyanide වල. ඊට පස්සේ on the spot මැරෙනවා. කොහොමද ඉන්නේ? ඒක මැරෙන්නේ ඒක හදලා තියෙන මොකද නැත්නම් ඇප් එකට අරන් ගියොත් එහෙම ගහලා ඉන්ෆෝමේෂන් ගන්නවා ඒක සයිනයිඩ් වලට කොල්ලගේ ටික දාලා ගන්න. ඒක කොහොමද? දැන් කාබන් මොනොක්සයිඩ් වලින් කරන්නේ හෙමෝග්ලෝබින් බ්ලොක් කරනවා. ඒකට ඔක්සිජන් නැතුව මාරන්නේ. සයිනයිඩ් කියන්නේ සයිනයිඩ් වලින් එන්සයිම්ස් ඔක්කොම ඉනර්ට් කරනවා. කාබන් මොනොක්සයිඩ් වලින් කෙලින්ම හෙමෝග්ලෝබින් එහෙම පිටින්ම ඉනැක්ටිව් කරනවා. ඒ වගේම තමයි cyanide වලින් කරන්නේ enzymes ඔක්කොම inactive වෙනවා. right? අපි දැන් අර glass එක කෑවට පස්සේ glass capsule එක කෑවට පස්සේ තුවාල වෙනවා කට. ලේ එනවා. ඒකෝනේ cyanide enter වෙනවා blood වලට. blood වලට ගියාගෙන ඊට පස්සේ heart එක යනවා. එහෙම ගන්නකොට ටක් ගාලා මුලෙන් ගියම cyanide යනවා. right? enzymes ටික එහෙම පිටින්ම ටික් ගාලා නතර. දැන් enzymes වැඩ නැහැ. එහෙම නේද? right enzymes වැඩ කරන්නේ නැතුව අපේ body එක function එක වැඩ කරනවා. ඒකයි cyanide වලින් බැරි. right? right. carbon monoxide වලින් බැරි තරම්. right. So then if you want to kill someone, so you can decide what method is going to be better. Right? Right. Hemoglobin. Right. Have you heard about collagen? Well, since collagen, this is actually one of the most abundant proteins in the human body. It's found in bones, muscles, skin, tendons, right? Basically, in the connective tissues. The strength is maintained by collagen. Strength is maintained by collagen. Well, collagen, have you heard about collagen as supplement? Right? Right. So when you grow old, අපේ යම් සෙට් එකක් තියෙන පාර collagen ගන්න නැතුව they can be collagen අර skin එක රැලි වැටෙනකොට හරි ඒ tension එක skin එක රැලි වෙනකොට ඒ tension එක තියාගන්න collagen තමයි ගන්න. ඒක collagen වලින් තමයි ඒ connective tissues වල strength එක ආපහු ඒ ගන්න maintain කරන්නේ. So this is like you know supplement wise something which has high demand to maintain the strength of the skin. And beauty culture, right? So to maintain the strength of the basically skin. Right. Basically, strength and elasticity, right? That is what is maintained. Well, when it comes to collagen, body also synthesizes. Collagen, body also synthesizes. Endogenous collagen, natural. Well, exogenous collagen, that is synthetic. That is the version that we take from supplements, collagen supplements, right? Like that. Correct. I remember when I was very young, when I was schooling, there was a house, one of the neighbors' house was like thrown in the night. And those two fellows used to fight, the husband and wife. They like fight out loud. Then I used to do something, I take some stones and throw like to this room and down deep. Like, then both of them stop fighting with each other. Then both of them told it like, then I feel so like that. So we can go on stores, like right. So so that is the pharmaceutical side of collagens. So basically to maintain the skin, collagen can be used. Right. So the structure of that is this. Right. So this is a structure, the molecular structure. Right. Clear, right? Right. Proteins. Now these proteins are highly sensitive for sensitive to certain conditions, right? High temperature and low temperature both. High temperature. Do you remember that in some countries people die because of high temperature, right? I think recently in India, right, people recorded died. That is because of high temperature. That's the maximum temperature that we can tolerate. Why? So then what is happening is, why do we die? Because, proteins are highly sensitive to temperature. When the temperature increases, then what is happening? Right. So then protein becomes denatured. Right? We call it protein becomes denatured. Right. So that means it changes. It changes. Uh, Sometimes it physically changes, sometimes it chemically changes. Think about an egg. We boil it, right? So if you just crack the egg, it is in the liquid form, isn't it? So the protein is in liquid form, right? We boil it and solid. With the temperature, it becomes solidified. Likewise, proteins are highly sensitive to conditions, right? So at high temperature, proteins become denatured. So when the temperature, when the outside temperature and output temperature increases, at some temperature, enzymes are proteins. So then enzymes are denatured. Basically, enzymes die. Now, when the enzymes are not present, definitely no chemical reaction is happening inside the body. Right? Chemical reactions are not happening. Since the chemical reactions are not happening, so it is not because of the heat that we die. It is because of the enzymes, because the enzymes can't tolerate the temperature. Enzymes are proteins, so those proteins denature because of high temperature. That's why we die, right? Right. That is because of high temperature. Not only high temperature, low temperature, even at low temperature. So therefore, proteins are sensitive to low temperatures as well. If the temperature becomes too low, then the proteins denature. Proteins die. Not only that, heavy metals, mercury, lead, cadmium, right? Heavy metals. Because of heavy metals, also proteins are going to be damaged because heavy metals are toxic to proteins. Why is that? Heavy metals, those metallic cations form new bonds with the protein molecule. In the protein is denatured, basically. The denaturing means changing the existing structure. That is denature, right? So if we change something about that protein, it can't do the same function. Example, දෙකක් මේ පුතු එක අකුලක් නැමුවොත් හරිද? කවුරුරට ඒක වාඩි වෙන්න බෑ. ඒ අර කැද ටික ඔක්කොම තියෙනවා. ඒක කකුලක් ඇදයි. වාඩි වෙන්න බෑ. වැඩේ වෙන්නේ නැහැ. So protein, same story, the same protein is there. But because of the new reaction that is happening with the heavy metal, now it is a different part. Still we can see something like that. Right. So this is like, so denaturing is that either it is broken, the protein, or else it reacts with something to form a new substance, which is different from the previous substance. Then previous substance function won't be happen. Right? Right. Some more factors which are badly happening, badly affecting proteins. Right? proteotoxic agents, uh, alcohols, right? Alcohols are toxic to proteins. And oxygen radicals. Radicals are, uh, let me take an example. Chlorine molecule. There is a covalent bond between chlorine and chlorine. If you break this bond, we get two chlorine free radicals with an unpaired electron right here. Right? Radical means something like this. This is a chlorine radical. If we break an oxygen molecule, oxygen radical, nitrogen radical. Likewise, so we can have radicals. So, so oxygen radicals, they are harmful. Cheroprops, there is urea and substances like chemicals. Right. And the pH value, acidity, basicity in the medium, pH value. Why pH value? Because proteins, they have acidic and basic chem. So if the medium is acidic, if we make the medium acidic or basic, that again reacts with the protein. Denatured function won't be done. Right. So those are the factors affecting on proteins. Well, speaking of how to test the protein, there is an experiment called biurate test. Remember in carbohydrates, we're talking about failings test, Benedict's test, and all. Likewise, to identify protein, there is a solution called biurate solution. We take the protein solution. If you already know that it's protein, you don't have to test. We take that suspected solution to be protein, right? That solution, right? And we get biurate solution, right? Well, it forms a blue ring. It forms a blue ring, and we really shake it. The blue ring disappears, and the solution turns purple into a purple color. Right. So that is our official identification test for protein. It is our good idea. Right. This is one of the tests which we can use to identify proteins. Clear? Right. So that's the end of the story. Hope you understood about proteins. Yeah. What are the doubts? No doubts. Any problems? Looking problem. Other than that, everything is fine. Reactions ചെയ്യാൻ පුළුවන්